Actually, it started when Yin and I, my partner in this, Dr. Shu Yin Lo, and I noticed a odd, peculiar catalytic effect in a particular water sample we had. So we had run a number of tests at Caltech at that time. Yin had a project at Caltech that I was helping on, which was a particle beam. We had the luxury of having the Caltech's labs, and we got sucked into a puzzle, and it was, why is this particular water doing what it's doing? He became so interested in water and began reading every paper that you'd go into his office, and place would be covered with all the papers he's reading on water. He pulled every piece of literature on water, and he kind of buried himself away for about a week in his office, until one morning I walked into my office and I was sitting down and having a cup of coffee, and he runs in and he says, "I know what it is." I know what it is. He says, "I've calculated it." And I thought, well, what did he calculate? And he sat down and said that he had written a mathematical model that explained what was going on with this particular water sample. And in truth, his model did. And to this day, it has predicted what we've found. But shortly after that, we knew then we were looking for a particle. I don't want to go into the necessarily the nitty-gritty of the science of it, but we knew we were looking for a particle, and so we started looking, trying to see it. At Caltech, there was an electron microscope there. I had run an electron microscope in numerous labs that we'd had before. I tried to photograph to find this particle in the water, but the problem was, since we knew so little about it, and when you're looking for something the first time with any kind of analytical equipment, it's not the easiest thing to do. It's like looking for a needle in a haystack. So we were unsuccessful in Caltech in finding any particle, but at that time we knew of a new microscope. This was in the mid-90s, about 95, 96, something like that. And there was a company in Santa Barbara at that time called Digital, and they were the first manufacturer of a microscope called an atomic force microscope. An atomic force microscope is a microscope that you can feel literally atoms, and a computer thinks with what it's feeling, and then it draws a picture of what it sees. So we came to Santa Barbara, and make a long story short, it was a grueling day. We thought we wasted all of our money. We only had so much money. We were paying for the microscope, we were paying for the operator, but at the end of the day, by absolute chance, we stumble over one of these particles. Because the problem with trying to find one is, until you really know a lot about it, you don't know exactly what you're looking for. An atomic force microscope, you have to tell it everything about the particle before you start looking for it. It's got to know how much pressure to put out there, how lightly to feel, and so it's not an easy task. But just by chance, we were leaving, and we'd spent all our money. The guy wanted to go home. Everybody in the place had gone home, and I convinced the guy just to show me what this microscope could do, and so he did. He said, well. He said, okay, and so he found a contaminant in this particular solution, and he started focusing more and more and more on this contaminant. And I was just impressed. I was really going, wow, that's unbelievable picture, because you're getting all this tremendous resolution on a particle that was so small. And then all of a sudden, as this microscope just draws one line at a time, and as it was drawing this picture, all of a sudden it starts drawing something that this big glob was sitting on. And so we're looking at this, and I said, well, what is that? And the guy looked at me and says, I don't know, I've never seen one of those before. And so it kept on drawing the picture, and then all of a sudden there was this rod-shaped looking particle, and it was white, and so I said, what, you don't know what it is? He says, no, I've never seen one before. And so I yelled at Yen. Yen was outside the room. I said, Yen, come in here. And he runs in, and Yen looks at it and he says, measure it. Because the original model had predicted that the particle would be a micron in diameter by 3 microns in length. That's how big they would grow to where they would stop growing. And the guy starts measuring it and uses this software to put some lines across and goes, like that. And he says, well, it's a micron in diameter and it's 3 microns in length. And so we just went, wow, we found our particle. So, that was 12, 13 years ago. And so the discovery was that a particle exists in water that we feel, this is what we feel, is a molecular state of water. It's a solid state of water. Happens not because of temperature, because of course you have liquid. You take some temperature out of it or cool it, it becomes ice. We know that is a solid state of water, ice. But liquid, and then if you add heat to the liquid, then you're going to get steam. Well, those are the known phases of water. This is another phase. It's an actual solid particle within water, and it forms because of particular kinds of just a particular set of circumstances. Well, the future of the discovery, good question. Because you understand that what we're dealing with is water. And whatever water affects, in other words, think of all the different things that water has effects on planet Earth. All biological life, plant life. I'm talking about all people and animals. So it's almost hard to predict how far this technology will go. You're dealing with a clean particle that's got a big charge to it. Now, if it uses water, let's say you want to make beer. Well, what do you make beer with? Well, you use hops, and basically you've got something, a sugar, an alcohol, something's got to turn to alcohol from a sugar. What's the main ingredient? Water. What's the main ingredient in wine? Water. What's the main ingredient in most food stocks? Water. And so it's an unlimited, I don't want to say future, it's just a potential. There's so many things that you could do with a charged water particle. You can make it all happen faster. I mean, I didn't answer your question very well, but the first thing we're doing with it is we can catalyze fuel with it. Well, now, how are you going to catalyze fuel? Well, normally you use something like platinum, well, or one of the other catalytic metals. Well, it's a little difference between platinum and water. What does water cost? An ounce of platinum costs what, almost $2,000 right now. What's an ounce of water cost? 2 cents? So a little bit of difference between the two. And but if you can take that same water, that 2 ounces of water, and do what 2 ounces of platinum can do, and now you're not adding any, in order to use platinum as a catalyst, you've got to lace it with something that's kind of a chloride or hexachloride, something that's kind of hot in order to get it to go in solution. What do I have to lace water with to make a catalyst? Nothing, water. So the first thing we're looking at is using it as a catalyst in fuel. And we've already done 12 years of work on that. We have it now to where we don't have to add an alcohol, we don't have to add a binder, which is some kind of chemical binder. We don't have to use a solvent or a detergent or anything like that to get it into the fuel, because all of those things are going to create some type of a byproduct, and most all of them they'll have some toxicity to it. Does water have a toxicity to it? No. Is water carcinogenic? No. Are detergents that are used in fuel carcinogenic? Yes. Are octane boosters, terribly carcinogenic? So you've got, clean, pure water, or you have some type of chemical that they're trying to use it to enhance combustion. So the first thing we're looking at is to enhance combustion. And we've already shown really across the board, we can honestly say we can give a 20% reduction in carbon right now on, across the board, across the planet. You could take the carbon load off of the planet by 20%. And we have spectacular results with older engines where they're already been used, some buses. We've done some recent tests, school buses. We've actually doubled their economy. Well, I can say, well, how can you double someone's economy? Well, because these buses originally only got 9 miles to a gallon. After 5-6 years in the field, they're now getting 4.5 miles to a gallon. Now we've taken a 9.5. So we've actually doubled their economy.